Okay, boys and girls, it's time to take a look at the independent practice. So by this point, hopefully you were able to try this on your own. If not, if you're still struggling, that's okay. You can always go back in your book and take a look at those pages that we've already done. You can go on to the YouTube page and look at some of the videos that we've already done. Or if you really feel like you need some extra practice, you can always email me and I can see what I can find. But let's take a look at the independent practice page. If you've already done this, great. If you're doing this on Edpuzzle, even better. If not, if you're not able to pull up Edpuzzle and maybe you weren't successful, just follow along. Okay? Elise picks 6 pounds of apples. She uses half a pound of apples to make 1 container of applesauce. Half a pound. So she's got 6 pounds and she uses a half a pound of apples to make 1 container of applesauce. How many containers of applesauce can Elise make with all the apples? Okay, let's see. We have 6 pounds of apples cut up into 1/2 pound containers. So in other words, if I have 6 whole pounds and each container uses a half a pound, I would be cutting each one of these in half, which is going to make 12 containers. Now, one other thing that I'd like to show you, boys and girls, is let's go back to that old school algorithm. Those of you parents that are looking at this, you might remember this from the way that we learned. We call it keep, change, flip. So we keep the first part the same, but we need to write it as a fraction. So 6 wholes is 6 over 1. We change the division sign to a multiplication sign, and we flip the last fraction, or what we would say inverse. So we're going to flip that around to make that 2 over 1, and then we multiply. And we find that 12 over 1 is the same thing as 12 wholes. So we've just checked our answer. So your answer is A. Okay. Number 2. Students are running in a relay race. Each team will run a total of 3 miles. Each member of a team will run 1/3 mile. How many students will a team need to complete the race? Circle the correct number below, and you may use the number line to help you. Okay. Each team will run a total of 3 miles. So here's our 3 miles I see on the number line. Mile 1, mile 2, mile 3. Okay. Each member of a team will run 1/3 of a mile. 1/3. Each team will run 3 miles. Each member of a team will run 1/3 of the mile. How many students will a team need to complete the race? Wow, interesting. So if, and I'm just going to redo this because that kind of helps me get thinking. If one student can run 1/3 of a mile, that puts them there, right? Each member of a team will run 1/3. How many students will a team need to complete the race? So that's one student right there. And then another 1/3 of a mile, 2/3, would be another student. And then another 1/3, 3/3, would be another student. So if I continued this process, 1 and 1/3 makes a 4th student. Can you see what I'm doing here? Another person. Another person. Another person. Another person. And another person. So we would need a team of 9 people so that each team member is running 1/3. So in other words, is that 3 whole miles cut up into 1/3 sections? Does that equal 9? Well, keep, change, flip says 3/1 times 3/1 equals 9. They made that one look tricky. I don't love the number line that they used. Again, perfect example of why I like the number line that I drew. But you can use whatever works for you. Okay, moving down here to number 3. Mr. Bernstein will cut 8 pies into pieces that are each 1/6 of the whole. So each piece is 1/6. So in other words, a pie is cut up into 6 pieces. Okay? And there are going to be 8 of those. So that would be 8 times 6, right? After he cuts the 8 pies, how many pieces will Mr. Bernstein have? That's so funny. I think I just figured that out by my picture. So 8 cut up into 1/6 should equal 48 pieces. Let's keep, let's change, and let's flip. Ta-da! So in other words, Mr. Bernstein has 48 pieces. Look at that. They're missing a period. Oh, no, I tell a lie. That's my fault. It's just a label. All right, number 4. Marina has a pattern to make bows that requires 1/4 yard of ribbon for each bow. So if I think about a yard, 1 yard, 1/4 makes 1 bow, 2/4 makes 2 bows, 3/4 makes 3 bows, and 4/4 makes 4 bows. So in 1 yard, she can make 4 bows. Fill in the table to show how many bows she can make from a given length of ribbon. I'm going to let you go ahead and solve that. Okay. The ribbon length. 1 yard makes how many bows? Well, I just drew a picture of that. 1 yard makes 4 bows. So if I have 2 yards, it's going to double that. And it's going to make 8 bows. If I have 3 yards, it's going to double that. And I'll be able to have 16. And 4 yards, I'm going to double that. Is that right? Let's see. 4 yards cut up into 1/4 pieces. Oh, wait, I see what I did. I'm doubling. I'm supposed to just add 4 more. Whoopsies. Okay, if I have 3 yards, that's another 4, so that's 12. Whoops. And if I have 4 yards, that's another 4, so that's 16. Sorry. Okay, use words or an equation to describe a rule. It's a little distracting in my house. Can you hear that? Use words or an equation to describe a rule to find the number of bows Marina can make if you know how many yards of ribbon she has. Think about that question. They want you to use words or write an equation to tell a rule that Marina could use to figure out how many yards of ribbon, to find the number of bows she can make if she knows how many yards of ribbon she has. So let's say Marina walks in and she says, oh, I just got more ribbon. I now have 15 yards of ribbon. And we need to tell her how she could figure out how many bows 15 yards would make. How would you tell her that? In words or in an equation? So if she has 15 yards, and I'm just using 15 as an example. Is there an equation you could write for that? Could you explain it in words? Well, what's happening each time? For every 1 yard, she gets 4 bows, right? So what would we do if it was 15 yards? What would we do if it were 5 yards? Are we adding 4 more bows? You notice anything? Oh, for every yard, it's 4. So if we added 6 yards, it'd be 4 more, and that'd be 24. So in other words, X number of yards, so however many yards Marina has, if you multiply that, I'm going to change that X to a question mark. However many yards Marina has, if you multiply that times 4, because that's how many bows you can make in each yard, that's going to tell you your total number of bows. So again, if she has 15 yards, she can get 4 bows out of those 15, each one of those yards. So if you multiply 15 times 4, that would tell you how many bows she can make. All right. Oh, look at this. You're going to use the rule that you just made to find out how many she could make if she had 18 yards. So if she has 18 yards, what can you do there? How many bows can she make? $18 yards times 4 bows per yard means that she can make 72 bows. Okay, so this is the end of the independent practice. There is no, this is the end of the independent practice as in the instruction book. There is no practice page. We've actually reached the end of the lesson. So here's my challenge for you. You are going to need to submit your work to me in some way, shape, or form. This week we're just trying it out, but after spring break you will need to submit your work to me. There's a couple of ways that we're going to do that, but my challenge for you today is to try to take a picture using your iPad or whatever you've got. Take a picture and email me or send me a class tag photo of your work. Now, for those of you that are ready for the challenge, if you go down to the optional box on today's lesson plan, you will see a video link to the quiz. I'm going to put the quiz up on a video and I'm going to have you try it out on paper pencil, or those of you that are able to get Edpuzzle, you can try it out on Edpuzzle. If you'd like to submit that quiz to me, that would be great.